All right, so this idea is what we call the multiplication rule. What the multiplication rule is now, instead of us making like one draw or just looking for a single probability, now we're going to actually do what we call multi-stage or multi experiments. And so this will be like I'm going to draw multiple times is really what it talks about. And what the multiplication rule says is if we're going to draw multiple times, like if I want this event to happen and then followed by another event and then followed by another event, I'm just going to take those individual probabilities and multiply them together. Okay. So again, if I want like an event A to occur, and then I'm going to draw again. So I draw a second time. This is where it changes from what we've been doing. The previous times we've only been doing something one time, and that's it. So now we're looking at doing or drawing or choosing multiple times. Okay. A little bit of notation. If you look at this example down here, we always follow that up with a comma right here. That comma tells us that I'm interested in event A, followed by event B. Okay. And then the other thing that's going to be really critical with this is we're gonna decide whether we have with or without replacement. We need to know whether this is with or without replacement. What that means is on the second draw or the third draw, or at least after the first one, are we going to put it back in or are we not? If it's with replacement, it's like you reset the draws to the exact same original thing that you're drawing from. If it's without, we assume that we keep the first one out and we don't put it back. Okay. So what you guys will see is we're going to do a couple things with replacement and without replacement here. Okay. We're going to use this example right here. This is an example of just a made up example, but it fits. So let's say we've got a sock full of drawers, and we know that there are 10 whites, 4 blacks, and 2 brown pairs that are in that drawer. And you're just going to randomly choose one pair and then another pair, and if you're doing a third pair. Okay. And so we want to know what the probabilities of these following are. So for example, on this first one right here, we want to know what the probability of getting a black on the first day and then getting a pair of browns on the second one without replacement. That means I'm not putting them back after I draw the first time. So all I do is I say, okay, well, how many, remember our probability is always interested over total, right? Outcomes. So I need to know how many total I have. Here I have 10, 4, and 2, which should give me 16 total. Okay. And so for this first one, what's the probability in a black pair of socks would be 4 out of 16 because there are 4 black pairs of socks and there's 16 totals. If I don't put it back, all of a sudden there's 1 less of the black. So now there are 3 pairs and there's 15 total. So the chance of getting a brown on the second one would be out of 15, but there are still 2 brown socks in this case. And then all we do is we just take this and we times these together to find our probabilities. So when I do that, I'm going to get 8, and then I just do 4 times 2 gives me 8. 16 times 15 gives me 240. And then because I want this is a percentage, I'm just going to go 8 divided by 240, and that gives me 0.03 repeating, which if I times that by 100 and put that as a percentage, that would be 3.33%. So not very high, but there's a chance of that occurring. Okay. If I look at this next one, this one wants a brown and then followed by the second with a brown, but this is still without replacement. So the chance of getting a brown, there are 2 browns when I start, and there's 16 total. So that'd be 2 out of 16. And then I'm not going to replace it. This is going to be without replacement. So now there's 1 less brown on there. So this one's now going to be out of 15. But this is only going to be 1 because there is a 1 less brown, whereas this other one, there was 1 less black. So, and then I'm just going to times these together. So this would give me 2 over a 240. And again, I'm going to divide those. 2 divided by 240 is going to give me 0.0083, which if you times that by 100% is 0.83. Oops, hold on just a second. Which is going to be 0.83%, which is not very high, obviously. So pretty low of that occurring as well, and we'd expect that. Okay, so if you look at this next one down here, now I'm going to draw 3 times, so I'm going to have 3 fractions, but this is going to be with replacement. So all that means is it just resets every time. It's like I put my dirty socks back in the drawer, okay, which is disgusting, but whatever. So on this first one, I've got, I want to know the probability of getting a white sock. That would be 10 out of 16, because there are 10 and 16 total. And then the second one, because I put it back in, it just resets to 10 out of 16. And then I want a white again, it's just going to reset again, 10 out of 16. And then because my multiplication rule just says, hey, we're going to times all these together to get what I need here for this. And so I just take my numerator and multiply 10 times 10 times 10 is going to give me 1,000, and then 16 times 16 times 16 gives me 4,096. And then I'll actually go ahead and divide those and times them by 100. And when I do that, I get when I just divide them, I get 0.2441, which that'll be 24.41%. And that'll be my answer on that one. Okay, so if I look at this next one, it's a white, then followed by a black, and then a brown with replacement, so it's resetting. So I'm still going to start with the 10 out of 16. Then the black is going to be 4 out of 16. And then brown is going to be 2 out of 16. Again, because it's resetting every single time. So that should be, I mean, hopefully you guys are seeing that should be pretty self-explanatory there when we get there. So this is 80, again, over 4,096. And then if I divide those two, I get 0.0195, which would give me 1.95% chance. So not very high to get one of each, but that's how we do that. Okay. I also want you guys to use the multiplication rule with a or a tree diagram is what they call this. This is a tree diagram. All this is doing is it's organizing my data, meaning event A is, so this is like tracking sandwiches and their bread and either ham or turkey. So this is a pretty simple tree diagram at let's say at a sandwich spot. And so the first thing you do is choose their bread. And so let's say there's a 30% chance of customers choosing wheat and 30 or 70% chance of choosing white. And then if they choose wheat, there's a 40% chance of ham, and there is a 60% chance of turkey. If they choose white, then it's 20/80. Okay. And so I've got 2 events here. This is going to be dependent on this. If we are using a two-way table, instead of using fractions, it's already as a decimal, so I'm just going to use the decimals here. So for example, let's answer a few different real simple questions. The first one just deals with a single event. So this first one's like, what's the probability of ordering a sandwich with white bread? That would just be 70% because of this 0.70. I just times it by 100. So that it's telling me what that probability is there. This next one's saying, what's the probability of ordering a sandwich with turkey on wheat? So I'm just going to follow the line. So wheat, turkey, that would be 30% and 60%. So I'm going to go 0.30 for my first event, and then I'm going to times it by 0.60. And I don't have to really worry about with or without replacement because this is already taking into account that. But I'm just going to times them because I want event A to occur and event B to occur already. This gives me 0.18, which is 18% here, okay? So I've got 70% on the first one. This would give me an 18% chance of that occurring. The next one's, let's actually look at look at this last one first, and then I'll come to this next one. So this last one wants a ham on white. So I'm just going to follow the line. So white is 70%, and then ham is 20%. So I'm going to go 0.70, and I'm going to times that by 0.20. That is going to give me 0.14, or a 14% chance of that occurring for that one. Okay, so just follow the line. It's actually a lot easier, I think, with tree diagrams. And then this last one wants the probability of ordering a sandwich with just ham. So it doesn't specify wheat or white. So I have to take into account both of those. So I'm going to do wheat and ham. Then we do white and ham, and I'm going to add them together. So wheat and ham would be 0.30 times 0.40. Okay, and that would give me 0.12. And then white ham would give me, we already did that one, that one's right down here. We'd go 0.70 times 0.20, and that would give me 0.14. And then I just add those two together. So I'm going to go, and this would be 12%, and this would be 14%. So when I add those two together, I go 12 plus 14. That's going to give me 28%. And that's what I'm looking for on that one. So you guys should be able to use that multiplication rule. That's just multiple events is what we're looking for in that case. Okay. All right. This has been Math Moment with Mommy. Adios.